Thank you, thank you, thank you. So good evening to all. Now we are entering into another one important topic for this particular subject, that is digital electronics. Is called digital logic circuits. Digital logic circuits. That means digital circuits, introduction to digital electronics. In this particular part, we are going to designing the digital logic circuits, or in your syllabus maybe logic families, DLF, digital logic family. What is mean by this? So which is the thing which you have studied in the earlier part of the subject. So நம்ம இதுக்கு முன்னாடி என்னென்னலாம் பார்த்துருக்கோமோ லாஜிக் ஃபேமிலிஸ், சேம் திங், only we are going to discussing but in different manner. வேற மாதிரி நம்ம பார்க்க போறோம். Say for example, the topic which we are going to discussing is digital logic families or digital logic switches. Anyway, so here again we are going to discussing AND logic, OR logic, NAND logic, NOR logic, everything. So இதெல்லாம் நமக்கு தெரியும் சார், based upon the fundamental logic gates, basic gates and derived gates உங்களுக்கு தெரியும். Basic gates are AND, NOT, and then OR gates. One is for logical multiplication and another one is for logical addition, another one is for inversion operation. So no doubt அதே தான் now also we are going to discussing, but here we are going to discussing the design of logic circuits. That means which is used in the memory, particularly in the memory part. Which logic we adopted, which logic is there in the digital logic circuits design. So in addition to this, some other designs is also there, that is programming logics. That programming is also so far discussed is different. Some other programming is also nowadays available. Say for example Verilog based, Xilinx based, and computer assembly language programming based designs. இது மாதிரி நிறைய இருக்குங்க சார். But anyhow, now we are going to discussing the important logic families that I listed here. That is RTL logic families, DTL logic families, TTL logic families, ECL logic families, MOS families. So this MOS families is again some other subdivisions also there. That is NMOS logic families and then PMOS logic families. So இதுதான் நம்ம இப்போ போய் டிஸ்கஸ் பண்ண போறோம் சார். There it is available. It is available in all the places, all the digital electronics. That means it is in the part of the memories, RA microprocessors, RA microcontrollers. மைக்ரோப்ராசஸர்ல ஒரு பார்ட்டா இருக்கலாம், மைக்ரோ கண்ட்ரோலர்ல இருக்கலாம், ஆல் த ப்ரோக்ராம்ஸ் we want to stored in a memoryல இருக்கலாம், PCஸ்ல இருக்கலாம், DSPs, that is digital signal processing unitல இருக்கலாம், or any other memory devices, எல்லா இடத்துலயுமே இதை யூஸ் பண்றாங்க சார். So the first logic family is RTL logic. RTL means resistor transistor logic. So RTL means resistor transistor logic. Very simple explanation. What is mean by this? For this, if suppose I'm going to explaining the logic families are the fundamental or a basic logic gates உங்களுக்கு தெரியும். Only 3 logic gates. One is inverter logic, another one is logical addition gate, another one is logical multiplication gate. So inverter is not gate. இன்வெர்ட்டருக்கு உங்களுக்கு என்னன்னு தெரியும், that is a not gate. ஒரு simple not gate தான் inverter. Then logical addition means which is used to add logically. அது என்னன்னு உங்களுக்கு தெரியும், that is OR logic gates. OR gate தான் நம்ம என்ன சொல்றோம், logical addition gate. Logical multiplication gate என்னங்க சார், that is AND logic gate. ஓகேவா? ஸோ இப்போ நம்ம என்ன இந்த பர்டிகுலர் டாபிக்ல we are going to discussing அப்படின்னா the same thing, NAND, OR, and then AND. These are all the basics. And then derived gates. இதெல்லாம் basic gates. இதெல்லாம் என்னங்க சார், basic gates. We are going to discussing also the derived gates. Derived gates என்னங்க சார், one is NAND gate. ஒரு கேட்டுக்கு பேர் என்னங்க சார், NAND gate. Nothing new, everything is already you know. Another one is NOR. And then next one is exclusively OR. And then one more thing is also possible, that is exclusively NOR. So the maximum first two only in all the situations we are going to using. But anyhow, these are all the derived gates. Derived means by using these gates we are going to make the gate or design a gate. Okay. So I think now a simple question: can you able to understand the definition of all the basic as well as derived gates according to its truth table? இந்த இதுல மொத்தம் ஒரு 6 கேட்ஸ் அல்லது 7 கேட் சொல்லியிருக்கிறேன். இதோட டெஃபினேஷன்ஸ் பேஸ்ட் ஆன் த ட்ரூத் டேபிள் தெரியுமா அப்படின்னா அதை தான் நம்ம we are going to verifying. இதை தான் நம்ம வெரிஃபை பண்ண போறோம். ஓகேங்களா? சே ஃபார் எக்ஸாம்பிள் இன்வெர்டர் கேட், தட் இஸ் நாட் கேட் ஆர் a not logic circuits. இந்த சர்க்யூட்டை we are going to explaining the using some electronic circuits, ஒரு digital electronic circuitsல பண்ண போறோம். Very simple. So you know the equivalent circuit for this not gate. Not gate க்கு ஒரு equivalent circuit என்ன அப்படின்னா a simple NPN transistor. Simple NPN transistor. If you are strong in the operation of NPN transistor, that is the inverter logic. And then R logic oda explanations I'm going to explaining RDL. RDL in the sense by using resistors and diodes for obtaining the attaining the truth table or output of a R logics. ஒரு R logic ஓட அவுட்புட்டை ரெசிஸ்டரும் டயோடையும் ஸ்விட்சஸையும் வச்சு அப்டைன் பண்றோம்னா அதுதான் RDL. Resistor diode logic families. ஓகேங்களா? which elements you are using to design a logic families based upon that the classifications. The first one is RTL, second one is DTL. So RTL means resistor transistor logic, DTL means diode transistor logic, TTL means transistor logic. So far these three classifications, so in the mono classification based upon the devices which we used to attain or to obtain the truth table of this logic families. In the logic families oda truth table இந்த மாதிரியான devices use பண்ணி by constructing a simple circuit we are going to verifying the outputs and the truth table verify பண்ண போறோம். சரிங்களா? And then the fourth one, ECL logic families. ECL means emitter coupled logic families. It is also similar to the transistor logic families, but with the connection based upon the connection it is classified emitter coupled logic. Emitter coupled logic, that means emitter of the transistor 1, emitter of the transistor 1 you might have studied in your electronic circuits. That means like this we are going to discussing in the forthcoming part. So like this, emitter to emitter may be coupled and then inputs are given like this. This is the A input, this is the B input, what is the output. So like this there is a formation of a circuit to realize either non-logic family or a NOR logic family, whatever may be the logic families or AND logic, எதை வேணாலும் நம்ம verify பண்ணலாங்க சார். So this is called, this particular thing is called emitter coupled. Emitter of a first device and the second device is coupled together either directly or back to back anyway. So this is called emitter coupled logic family. Okay, then MOS families. Next logic families is called Mosfets. So by using Mosfets also we can realize the output or operation of all the logics. So it may be either N or P type, N MOSFET or P MOSFET. Based upon that, NMOS logic families, PMOS logic families, and then complementary MOS, CMOS, complementary MOS. So totally 3 classifications. So இப்போ இதோட கிளாசிஃபிகேஷன்ஸ் லாஜிக் ஃபேமிலிஸ் எல்லாத்தையும் பார்த்துட்டோம், வேர் இட் இஸ் அடாப்டட்னு அல்லது அப்ளிகபிள்னு பார்த்துட்டோம். இதெல்லாம் எதை போய் படிக்க போறோம் அப்படின்னா நத்திங் நியூ, ஆல் த லாஜிக் ஃபேமிலிஸ் இஸ் கோயிங் டு எக்ஸ்பிளைன் a certain basic or a derived or both இந்த கேட்டோட ஏதாவது ஒரு கேட்டோட அவுட்புட்டையோ அல்லது இந்த லாஜிக் ஃபேமிலிஸோட அவுட்புட்டையோ வெரிஃபை பண்ண போறோம். தட்ஸ் ஆல், வெரி சிம்பிள். ஸோ அதுக்கு தான் இந்த பர்டிகுலர் டாபிக். ஓகே, நவ் so the same thing only here. I'm straight away entering into the subject. Before that, some fundamental reflection. So whatever the things we are going to discussing, that reflects the same thing. That means binary logics. Binary logics. You know what are the binary logics? Only two logics. One is 0, another one is 1. One is 0 and another one is 1. The same thing may be represented in different authors as low and high, as well as false, as well as true. False as well as true. So in some other practical books, it may be like this: +5 and -5, +5 VCC and -5 VCC. ரொம்ப கேர்ஃபுல்லா நோட் பண்ணிக்கிங்க, because some books are there for this particular topic. Say for example, digital logic circuits designed by Zonde அப்படின்னு ஒரு புக் இருக்கு. ஆத்தர் சோண்டேன்னு ஒரு ஆத்தர் புக் இருக்கு. அதுல நீங்க போய் பாத்தீங்கன்னா there is no like this kinds of explanation, either 0 1 logic or a true false, on and off, opening and close, low and high, அப்படிலாம் இருக்காதுங்க சார். Instead of that, like this, practical values of the circuit is only given. இந்த மாதிரி practical values only given in it. So accordingly you have to understand. So it reflects only the binary logics, that is either 0 and 1 in any format. சரியா? It may be in any logic, either positive logic conversion or a negative logic conversion, whatever may be the thing. So here, which one is going to, just a minute please. So we are going to testing the following things: either inverter gate or AND gate or OR gate, NAND gate, NOR gate, and etc. So all the gates families oda operations தான் check பண்ண போறோம். That's all. So this is the simple circuit of our understanding what I am going to explaining, or what we are going to discussing in this particular chapter. So this is the logic gate. One logic gate is taken here. That is sample is logical multiplication, and AND gate is a logical multiplication gate. You know the truth table for this. Say for example, input is A and B, two input logical multiplication gate. Output may be X, whatever may be things. So your input is 0 0 means what? 0 1 means what? 1 0 means what? 1 1 means what? So both are 0 means 0, 0 1 means 0, 1 0 means 0, 1 1 means 1. So according to the truth table, what is the definition for this? What is the definition for this? That means, so according to the definition of a unlogic circuit, according to this truth table, in the truth table வச்சு நம்ம define பண்ண போறோம். எப்படி define பண்ண போறோம்? If any one of the input is 0, any one of the input is 0, output equal to 0. So ஏதாவது ஒரு இன்புட் எனக்கு 0வா இருந்துச்சுனாலும் என்னோட output equal to 0. சரிங்களா? Or if any one of the all the inputs are high, output will be high. எல்லா அவுட்புட்டும் ஒண்ணா இருந்துச்சுன்னா அவுட்புட் ஒண்ணுன்னு ஆயிடும். That's all. Okay. So the same thing only we are going to verifying here. For that, this is the equivalent circuit. This is the equivalent circuit. So this circuit is constructed. This circuit is constructed by using what? By using what? By using certain devices, logical devices. That is diode. இங்க என்னத்தை யூஸ் பண்ணீங்க சார் அதை கன்ஸ்ட்ரக்ட் பண்ணிருக்காங்க? By using diodes and resistor. Diode and resistor. So we called this as RDL, resistor, diode, logic family. So this is called RDL logic family. Similarly, if suppose the circuit is designed by using a transistor instead of this diode and resistor, that is called resistor transistor logic. Okay, I think you can understand what I am going to explaining in this particular part. So it is a simple circuit or equivalent circuit of a logical multiplication gate. It is a logical multiplication gate and it's a switching operations already you know the truth table. Just now I explained both inputs are 1 means output will be 1, otherwise the output will be 0. Output will be 0. If any one of the input is 0, output will be 0, or all the inputs are 1. All the inputs are 1, output will be 1. The same thing only we are going to discussing. So listen carefully. So initially, I'm going to take my A input equal to 0 and B input is also 0. A is 0 and B is also 0. A equal to 0 and B equal to 0. So what will happen? For this you should strong in your fundamental. So this is plus VCC. This is plus VCC. Here the input is 0, which is equivalent to ground. That means like this. That means like this, which is equivalent to ground since it is a 0 logic. So now you have to check the status of this diode status. The anode of this diode is connected to plus VCC. My anode of the diode is connected to plus VCC. Very simple if you are strong in fundamental. So the anode of the diode is connected to plus VCC and then cathode of the diode is connected to minus VCC or a ground. Minus VCC or a ground. What will happen? Now the switch is under forward bias condition. It means that what it is acted as a on switch. On switch means what? It is a short circuited condition. It is a short circuited condition. That's all. If suppose it's opposite, another one condition is also there. What is that? My anode of the diode is negative and cathode may be positive. Under this condition, this is called a reverse bias condition. This is called a reverse bias condition. And then now it is called off switch. Now it is called off switch. Off switch means what? It is acted as a open switch. It is acted as a open switch. So now the switch is under open circuited condition. Okay, this fundamental is sufficient to understand this logic family. So I'm going to explaining the operation of AND logic by using which concept? RDL, resistor diode logic. Okay, why we called this as a resistor diode logic? Because the circuit is constructed by using only the elements resistor, diode and biasing plus VCC. That's all. Okay, yes, now we are going to checking the operation. That means 0 0 inputs. A equal to 0, my A input and B input is 0 0. A input and B input is 0 0. What is the output? Say for example Y as the output or Z as the output. Okay, so A and B equal to 0. Now this is VCC, this is ground, here also ground under this condition. What will happen? So the switch is acted as a short circuit. Here also the switch is acted as a short circuited condition. So what will happen? So it is a short circuited means which is directly connected to ground. Therefore my output is equal to 0. Because it is a short circuited. All my voltages is going to ground. Either this path or both. Okay. This is the first operating condition. Similarly, the second one. So instead of A equal to 0, B equal to 1, I am taking the condition A equal to 0 and B equal to 1. Now, this diode is under forward bias condition. Please listen carefully, nothing new. Already you know, but you have to explain in this way. So this device is now under reverse bias condition. So this is forward bias, this is reverse bias, because the cathode of the device D2 diode is connected to plus VCC here, INGI plus VCC. Okay, then here also plus VCC. If the plus VC applied here is greater than this, what will happen? This device is under reverse bias condition. So open circuited. What will happen? Now all the source voltage is directly going to ground. So second condition is also verified. Then third one. So I'm going to check this. So now I'm going to take my A input is 1, B input is equal to 0. A input is equal to 1, B input is equal to 0. Now what will happen? So this device is under forward bias. Correct? Am I correct? This is under reverse bias. Am I correct? Anyone? Azaruddin? Anyone please reply? Ajay, Bharat Kumar, Dilip Kumar, Gayatri. Anyone? Gayatri, Hari Krishna. Hari Krishnan.
Yes, sir.
Yes, tell me.
Network problem, sir.
Network problem. Okay, anyone, any other person can explain. Either Gayatri or Jayakumar or Madan or Manju, Muhammad Azaruddin. Anyone please explain. So now my A input equal to 1, B input is equal to 0. Under this situation, this device is forward bias or reverse bias? Switch 1 is under forward bias condition or reverse bias condition? Azaruddin? Murugan, who is Murugan? Ratanavel, Santosh Kumar.
Diode one reverse bias, sir.
Yes, diode one is definitely reverse bias because cathode is connected to again plus VCC, anode is also plus VCC. According to the voltage level, we can determine. But anyhow, here it is 1, it is reverse bias. This is forward bias condition. Okay, it is reverse bias, this is forward bias condition. So under this condition, this plus VCC is directly connected to ground through this path. So all the charges available here is directly connected to ground, Then we are going to check the last one. That means this condition. When both inputs are 1, 1, A equal to 1, as well as B is also 1. So under this situation, my device, this one is also reverse bias. This switch is also under reverse bias. That means open circuited condition. Therefore, there is no short circuited. Both are in an open circuited condition. So the supply will be comes till this point and also till this point. So whatever it is. So under this situation, whatever the minimum drop across this, or whatever the voltage across this resistance, that will be appear here. So which is approximately equal to VCC, that is high. VCC means high. So now this is the first logic family we are going to explaining here, that is RDL, resistor diode based AND gate. So in our examination also, the question may be like this: explain in detail with a suitable circuit diagram of RDL logic family to verify the AND logic gates or logical multiplication gate. What you have to do? You have to write the AND logic truth table, and it's a simple equivalent circuit, and then this exact circuit by using resistor, diode and plus VCC. So this is RDL family. Then you have to verify all the conditions, inputs and outputs. That's all. So like this, you can explain the same thing by using a transistor logic, transistor logic, or resistor transistor logic, or emitter coupled logic, anything, any other thing you can explain, no problem. Okay. So any doubt in this regard? So any doubt? I summarize the operation of this particular slide. So for the fundamental is you should know what is meant by logics. Which logic you are going to explaining. Anda, Ara, Nanda, not Geta, adoda logic. And it's truth table. So this is the first and foremost thing you should keep it in your mind. And then second one is a truth table. And then third one is the fundamentals of operation of a device. If it is diode means its operating conditions. If it is transistor means when it is under on condition, when it is under off condition. If it is on means high logic or low logic, off means high logic or low logic. That's sufficient to understand. Okay, that's all the first logic family operation. Any doubts? Any doubt? Pradeep, you need any clarification? If not, we can move to next. Yes, tell me please. So similarly, you can explain the logic families of OR logic family. Same way, in the same way, we can explain the OR logic family by using this logic circuit. That is, this is the equivalent circuit. You please compare this diagram and previous one. So there, this particular part is connected to plus VCC from this terminal. That means from here, it is connected to plus VCC. Okay, but here it is connected to ground. But here it is connected to ground. And also, you please look into here. There the switches, two switches are connected in series. Since it is a logical multiplication gate, here the switches are connected in parallel. That's all. And then its truth table is also you familiar. According to the inputs, both inputs are 0, output will be 0. If any one of the input is 1, output will be 1. Output will be 1. All the inputs are 1 is also 1. So the truth table is just previous things opposite. So if any one of the input is 1, either here or here or here, whatever may be the thing. So if any one of the input is 1, output will be 1 or a high. All the applied inputs are 0. My output is equal to 0. That's all. So this is again resistor, diode, logic based or logic family. So important question in our in semester examination. So this is another one thing. Similarly, you can explain RDL based transistor, RDL based other non-logic families, etc. Okay. So with this, I'm stopped today's session. If any doubts you want to clarify with me, you can ask. Otherwise, you can leave. Pradeep, Ratanavel, Murugan, Santosh Kumar, Satya. Dilip Kumar. Gayatri, Ajay. Ajay. Yohavani. No one reply. Can I put it as absent for this session? Bharat Kumar. It's okay. Otherwise, you can